First of all, we understood a function. It is something like, you have x squared, or it can be f of x is equal to 3x squared plus 2x plus 5. These are called functions also. They are also called polynomials. Polynomials we learnt in the 10th standard and all. See, this is some x to the power of something. You have some x to the power of something, then it's a polynomial. See, in this case there are three terms. Three terms are there, and therefore it is called trinomial. If you have only one term, it's called a monomial. If you have two terms like 2x plus 3, anywhere two terms are there, that's called a binomial. So if you have more number of terms, then they are called polynomials. Okay. So what is a function? In the first couple of classes I said, if you have like that set theory notation, I said f of x equal to say 2x plus 3, x equal to 1, then you will have 2 into 1 plus 3, that is 2 plus 3 5. So this is x value, this is a f of x value. When x equal to 2, you are mapping that to 7. Okay. So remember vertical line test I explained, and functions, and then so if you do the other way, like if I say f inverse x, okay, that means we are doing from here to here. Okay, that means this way is f inverse, this is normal f. So for example, in order to find out this inverse of the function, okay, we'll assume that y is equal to 2x plus 3, then y minus 3 equal to 2x, x is equal to y minus 3 by 2. Okay, this is called the inverse of that function. I'll explain to you in the next page again. So y minus 3 by 2. So if I take that, so f of x equal to 2x plus 3, f inverse x equal to x minus 3 by 2. Actually it was y minus 3 by 2, because we want everything in terms of x, that becomes x minus 3 by 2. What this means, you will see, I'll explain here. If I give 1, 2 into 1 plus 3, it is mapped to 5. If I give 2, it's mapping to 7. If I give 0, it's mapping to 3, like that. Now in this, let's suppose I give f inverse of 5. So 5 minus 3 divided by 2, 2 by 2 is equal to 1. So inverse, if you are going this way, so you are doing f inverse of 5, so you got as 1. Next you try f inverse of 3, you get f inverse of 3. 3 minus 3 divided by 2, 0 by 2, so it's 0. So it's mapping to 0. So this is a function, and the reverse is a inverse function. And we learnt inverse trigonometry. At that time I explained, inverse function. One is a trigonometric function. F of x is a trigonometric function. F inverse of x, if you want to have something like sine inverse x. So we already learnt function, inverse of a function. Okay. So functions are differentiable, meaning first thing, function means it is varying. Okay. What is a function? Function can be any function we can draw. We can draw as a curve. So for example, 2x plus 3, if f of x is equal to 2x plus 3, then it will be something like straight line. This is 3 and slope is the slope, if you take that y is 2, the slope is 2, m is 2, and y is equal to mx plus c. So if you have f of x equal to x squared, then that comes like this graph. This is x values, and this is the x square values. So f of x equal to say e power x. At e power 0 it's 1, so and then e power 1 is equal to something, e power 2 is equal to something, e power 3 will be increasing like that. So if I have like this function, so this is the exponential function, keeps on going. Okay, so what is that we are trying to say? These are all having no break. If there is no break, that is called continuous function. That means it's a continuous function. So continuous function, if there is a continuous function, then we say we can differentiate that. A continuous function can be differentiated, and this is a symbol. D by dx means differentiate. Differentiate with respect to x, because x is there. If I have d by dt, then differentiate with respect to t. If I have d by dk, differentiate with respect to k, whatever. So what we differentiate here, we are differentiating this f of x. If it is g of t, then we differentiate g of t with respect to t. So whatever is the variable here, the same thing we use here. This is a notation. Okay, this is a notation. So something like we have square root of x, logarithm of x. These are notations, right? Here you are doing a square root function, means square root operation. Here you are doing log operation. In this case, you are doing a differentiation operation. Okay, that's called a differentiation symbol. Okay, this and all won't come for exam, whatever I said just now. Okay, but this is the fundamental so that you can remember. Now we have got some set of rules. Okay, that's what we'll be practicing for next 10 minutes. Okay, the first rule is, if the function differentiation of x to the power of n, the rule is n into x to the power of n minus 1. So to read as differentiation of x to the power of n is n into x to the power of n minus 1. This is actually called a power rule. Power rule. Why? Because we are having some power here. Okay. So this is the important thing. This rule we will be practicing now. Okay. So I would be asking question, differentiation of x cube. How much? 3 into x square. Right? Good. Differentiation of x to the power of 1. 1 into x raised to 0. Good. So the differentiation of x to the power of 0 is 1. So it's 1. This is the important thing. Okay, we'll always have a problem. The other way to remember this also is differentiation of x by differentiation of x. See, this is also only x to the power of 1, right? So both are same, isn't it? Numerator, denominator. You will have 1. Okay. So differentiation of 3x cube. In such a case, right, this is only like a security guard, okay, for this fellow. So you don't so you just keep the 3 like that only. For this you write this 3x squared. So the answer is 9x squared. So same thing, d by dx of 3x. 3 will be like that only. So for that 1, so the answer is 3. Any questions on this? No questions. Okay, good. Now a constant alone its differentiation is 0. Alone means, for example, differentiation of 3 is 0. Got it, right? Because it's alone. Differentiation of 3x is not 0 because this fellow is not alone. He is with a x, right? That's why the answer is 3 into differentiation of x, which is 1. Because this is the one of the common mistakes students do, and then they keep on asking. Many times they ask. Okay. So now simplest we will start. D by dx of 3 plus 5x. So when you have like this, you have to do the differentiation for this, plus you have to do plus differentiation for this. It's like algebra. Okay. So first one, differentiation of 3 is 0. Why? Because it's alone. Then for 5x, it's a 5. So the answer is 5. Okay. Now I'll take a little complex one. D by dx 5x squared minus 6x plus 1. Do you think you can do? You can tell me the answer. Yeah, sure. Yeah. So I am asking differentiation of what you see on the screen, 5x squared minus 6x plus 1. So same rule. You have to differentiate this first. How much is the differentiation of 5x squared? Okay, so let's go backwards. Differentiation of 3x cube. How did we do? 3 will be like that only. Okay, now tell me for differentiation of 5x square how much? 5. No. Try one more time. No, ma. No, no, no. See, just look. This, for this, right? This is called a monkey on the top kind of a thing. It is there on the top, right? So 5 like that only. 2 will come because this 2 is there into x to the power of 2 minus 1. We applied the rule, minus 6 into 1. If it is x, only 1 is the differentiation, plus 0. 10x minus 6 is the answer. Can I give some more? Some more questions? Okay. Only when you practice you will actually know. Okay. Because constant, I told, no, for constant alone, because this fellow is alone as a term. Understood, right? It's alone as a term. So that's how you got it 0. Now I'll ask the same question. D by dx of 100,000 plus x, how much? Good, that's correct. Okay, next question. D by dx of minus x plus half. Good, correct. D by dx of x square. It will be 1 less than that. It will be 1 less 2x. Good, correct. So d by dx of 2x square. Hmm. 4x. Yeah, 2 into 2x, which is 4x. Okay. Next one, d by dx of 2x squared plus x. Good, correct. 4x plus 1, correct. We can't add. It is not 5x. Okay. Yeah, okay. Yeah, yeah. I know you're just doing. That's why I just wanted to stop there. Okay. Next one, d by dx of 10x squared plus half x minus 1. Over. Just, yeah, this is the answer. Correct. 0. Okay. So now you are getting hang of it, right? Yeah. Yeah. Correct. So next question. We keep practicing. Okay. Yeah. You're doing it right. Hmm. You can give me a final answer. Should be 1 less than that. Ah. Plus. Ah. Correct. No, wait a minute. Here you said 1 by 3. What happened to this 3 should come in the forward, right? Here just like the 4 came in the front, isn't it? Yeah, correct. 3 gets cancelled. X square minus 2x. Then 0. Good. Correct answer. So this becomes 4 gets cancelled. We'll have minus 3x cube plus x squared minus 2x plus 1. Okay. This is the differentiation of that particular function. Okay. So now we'll have to do something difficult in this itself. Okay. Again, I'll write the formula. Differentiation of x to the power of n equal to n into x to the power of n minus 1. So that n will come into the front, and this is 1 less than this. Okay, like that. This is the formula. Now I am asking, what's the differentiation of 3t squared plus 2? Yeah, correct. See, that's why you have to observe same thing is there or not. Okay. Whatever is here should be same thing. Plus 0. So that is 60. Correct? Okay. Now we are continuing. I need some more because I would like, because once you know do not, this first day should be a slower and the differentiation. Afterwards we'll do fast, but today let's go slow. Okay. Um, Same question, whatever I asked, I just change a little bit. Ah, see, as long as you have this and this different, right? 0 only. Okay, because we, this is not the same thing. So this and this together is a constant, so you'll get a 0. Got it? So this kind of questions will come. So you can have something like d by dt plus 3t square plus sine alpha. That's all good. 60 only. Okay. Now I'll come back to 3 d by dx of 3x squared plus 2t plus 5. I changed to x. Okay. Okay. This is it. Right? So far these are all easy things. Okay. Then the next part is the same thing. If I have a negative, I got x to the power of minus 20. Rule is same thing. That means minus 20 x to the power of minus 20 minus 1. Now you may be saying, sir, I am getting now minus 20 x to the power of minus 21. You told me always this will be 1 less. Yeah, minus 21 is less than minus 20. Got it, right? That's what the answer for this. So we have a question now for you with the negative exponents. D by dx of x to the power of minus 2 plus x to the power of minus 1 plus 2. How much? So did you say minus 2? You said minus 2 minus 1, right? Ah, okay, yeah. So that's the answer for the minus 2 to the 2x to the power of minus 3 minus x to the power of minus 2. 1 is silent there. So this is the answer. Okay. So these all small algebra mistakes we will do. Okay. I am giving now minus half x to the power of minus 2 plus x to the power of minus 5. Give me the answer. Minus 6. Correct. Good. So this you understood, right? How you got plus 1 here. Yeah. Okay. So these are all the things which are doing with the polynomials. Okay. These are the simple thing. Now I'll give you set of rules. Okay. We only had one rule, which is called a power rule. Okay. I'll be giving you the lot more now that you may have to memorize, if not today, some other day. Okay. differentiation of e power x is e power x, no change. Differentiation of log x equal to 1 by x. Differentiation of sin x equal to cos x. Differentiation of cos x equal to minus sin x. Differentiation of tan x equal to secant squared x. Differentiation of secant x equal to secant x tan x. Differentiation of cot x equal to minus cosecant squared x. Differentiation of cosecant x is minus cosecant x cot x. And one last one. Differentiation, not last one actually, many are there. Differentiation of a to the power of x is a to the power of x into log a. So how many have? 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 8 plus 1, 9, and the first one what we said, x to the power of n, 10 are there totally. This 10 formula are important. Why? I'll give you here itself why you need to memorize that. Just like the way we have function inverse function, for differentiation integration is the inverse operation. Integration is inverse operation, and its symbol is this way. Okay, so d by dx of sin x is cos x, so integral of cos x will be inverse, so it will be sin x. So this is the reason, if you memorize all these things, the reverse, that means for the integration you are ready already, you're getting ready, which means integration of e power x is e power x, integration of cos x is sin x, integration of secant squared x is tan x, integration of minus cosecant squared x is cot x, integration of a power x log a equal to a power x, like that. Got it, right? We don't do the integration now, but it will come later, maybe after a few months. But this is this is the importance of memorizing it. Okay, now next part. So this I think we can erase completely, we don't need this. So here, so we will do some combination of what we learned. So we are trying to do d by dx of e power x plus sin x plus x. So we refer to the table back. For the first one, same thing, e power x. For the sin x, it is cos x, and for x, 1. Got it, right? So this is the answer for that. Now let's see another one, d by dx sin x plus cos x. Differentiation of sin x is cos x. Differentiation of cos x is minus sin x. So that's the answer. So far looks so easy, right? Not very difficult. Kind of. Okay, good. Now there are something called further rules. The rules are UV rule, U by V rule. What it means? These are used when you have product of two functions, product of functions. That means two functions you are multiplying. Then you use UV rule. This one is quotient rule, quotient of functions. That means this one will be like f of x into g of x. This will be like f of x divided by g of x. Okay, so these rules, without learning these, whatever I am telling today, absolutely nobody can say they have completed differentiation. That means all these things will be coming up to the last chapters. This rule will be used again and again and again. Okay, so what is that UV rule? Now we will see what is that UV rule. So when do we use UV rule? Okay, UV rule, you will see most number of times x coming. X are variable. What it means is, if I have x into sin x, see 2 times x is coming, right? So this is UV rule to be used. UV rule to be used. Sin x square, not UV rule. No UV, because 2 times function is not there. Okay. For example, I have 3x square. No UV rule. Okay, differentiation, no UV rule. Okay. I have e power x cos x. Yes, UV rule. Because this is one function, this is another function. Next, e power x plus cos x. No UV rule. I should say number of times x coming, and that's also multiplication. So these are some, because you will get some confusion later on with another rule called a chain rule. Chain rule, and this you will see when to apply, what to apply. That's why I'm making sure this is the actually clarification for that UV rule. So what is that UV rule? So if you have differentiation of two functions, then there is a notation. If I call f dash x, this means d by differentiation of the f of x. Anywhere dash means that. Okay, so f dash x gx plus f of x g dash x. This is the answer. So what is he saying? Differentiate the first function, multiply with the second function, then keep the first function same, don't differentiate, multiply with the second differentiation. I'll give you an example. Why we call that UV rule? It's a short form to remember. D by dx of UV equal to u dash v plus uv dash. Got it, right? This is why they call uv. U dash, you read it as u dash v. Okay, this is not raised. U dash v plus u v dash. That's how you read it. Okay, so what is the other rule? U by v rule, because it's easy to remember now itself. You get a v square here at the bottom denominator. In the numerator, u dash v and uv dash, you have both same thing as top, but you will have here minus. Got it, right? So that's all is the difference. Now I'll keep on demonstrating something for this uv rule and u dash v. Okay, very useful. So the first example is d by dx of x sin x. So it is a good practice to do exactly the same way I say. Okay, so identify. You write this as a u is equal to x. This one v is equal to sin x. Now you need to find u dash. What is u dash? D by dx of x. V dash also keep it. D by dx of sin x. In the first few questions you do. Later on you can skip this step. Okay. So what is d by dx of x? 1. Good. So what is d by dx of sin x? Cos x. Now I will apply the rule, which is u dash v. You have to write it in the exam. U dash v plus uv dash. That's equal to u dash is 1 into v is this sin x plus u is x, v dash is cos x. So this is the final answer, sin x plus x cos x. Okay. Now another rule, another example. E power x sin x. So u is equal to e power x, v is equal to sin x, u dash is same thing, e power x only, v dash equal to cos x. So applying this formula here, u dash this into this, u dash v. So e power x sin x and then this plus e power x cos x. Any questions? Understood? Okay. Now d by dx, question for you now. Okay, d by dx of sin x into cos x. So good, u is equal to sin x, v is equal to cos x. U dash is, yeah, v dash is, very good, minus sin x. So now the formula is this plus this into this. Okay, so the answer is u dash v plus uv dash, which is equal to cos x into cos x, which is cos squared x, this into this minus sin squared x. That's the answer. Okay, if you simplify it, this becomes actually cos square x minus sin squared x equal to cos 2x. Okay, that's a cos 2x. Okay, okay, now so we need to be doing another question. So u is equal to x, v is equal to, okay, so u dash is 1, v dash is secant squared x. Okay. No, secant squared x. So today I will help, but next time and all you must be keeping them in the memory. Okay. So now u dash v plus uv dash. So u dash v plus uv dash, that's equal to x secant squared x plus tan x. This is the answer for this. Okay. Some more questions. Differentiation of log x equal to 1. So now, sorry, 1 by x. So differentiation of x log x we want to see. U is equal to x, v is equal to log x. U dash equal to 1, v dash equal to 1 by x. So the formula is u dash v plus uv dash, that's equal to 1 into log x plus x into 1 by x. So this x gets cancelled. So log x plus 1. Clear? Now you have to tell me how do we do this. You can do it in the notebook and you can tell the answer, final answer. No, not correct. So this you have to do separately, this separately. In this, this is u, this is v. Because only you have to, when they are multiplying only you can use UV rule. Because this is minus, right? Let's go back to previous pages. See, we did this page here, right? These are like additions. Two different functions are there. The top one. I'm not talking about the bottom one. Oops. 1 second. I think it's this one is gone. I think, right? Sharing is gone. Okay. So see, these are like addition, different functions, not multiplication. Okay. So how do you do? Correct. That is separate one. Yeah, correct. Hmm. Good. Minus sin x. Good. So we have these things. So now for this first one, 3x into this, 3x, that means minus you put in the front, 3x sin x, plus this into this, 3 cos x. So we have done only for this now. No, no, no. I use this one only. U dash v plus uv dash. U dash v. Oh, 3x I had put it here. Ah, okay, okay. Ah, okay. You're right. So 3 cos x this way minus 3x sin x, this one, right? Then for this you put minus symbol anyway is there. For sin x, what's the differentiation? Cos x. So here 3 cos x, this is minus 1 cos x, so you'll have 2 cos x, simplifying. Then remaining thing will be like that only, 3x sin x. Understood? One more question you will have to do. D by dx of e power x cos x plus x log x. It's actually two questions. You have to do for this separately, and then add it. Okay. You do it in the notes and give me the final answer. Oh, formula I forgot. Or for e power x is 0 is x only, same. Okay, I'll give you the clues. D by e power x, d by dx of cos x equal to minus sin x, d by dx of log x equal to 1 by x, and of course d by dx of x. you know it is 1. Correct. Good. So I'll write the answer. Okay. So e power x, and as you said, for e power x it will be like that only. This is u dash, v is cos x, then your minus e power x sin x plus 1 plus log x. Correct? This is the answer. Okay, so we are doing good. Now let's take this tan x plus secant x. No UV rule. Okay, it's just addition. Okay. No UV. No. This is just addition rule, right? We are not multiplying. Correct? I just want to give tricks in between, so that you understand. Hmm. Correct. Plus for secant x tan x. Okay. So this is important. Why? Like 1 mark questions, many times this can come as 1 mark question. You take secant x common, then you have secant x plus tan x. This is the actual answer. But you see something, whatever is there in the question is coming again, right, in answer. That's why I just want to. So if you want to write it, actually this is same as if they say this is f of x. For example, this entire thing is f of x. In the answer you will have secant x into f of x. Okay, that's kind of a thing. That's why I gave this question. Next one, let's suppose we have secant x minus tan x. You can do the next question. Secant x minus tan x. Okay, so you got the same thing. Okay, now if you are not confused, then let's see whether I have any questions in the textbook. Straight away we can do, otherwise we will These are all the chain rule questions you have. In this UV rule, U by V rule, you don't have the things. So let me give you that quotient rule questions now. So we are now practicing U by V rule. So the answer is d by dx of some U by V equals to V squared U dash V minus UV dash. So this minus is one important thing, V square is important thing. Let's suppose now we want to do d by dx of tan x. We know the answer is secant squared x. Okay, we know it is secant squared x, and we would like to prove that using this U by V rule. D by dx, how do we write tan x? Sin x by cos x. So U is this, V is this. So U dash equal to cos x, V dash equal to minus sin x. So U dash V minus UV dash equal to U dash cos x into V cos square x minus U is sin x into minus sin x. So this becomes cos squared x plus sin squared x. Correct? So this is our numerator. Okay. So the answer will be minus U V square. V square is V square cos square x plus sin square x. This is what we got, numerator, divided by V square. V is cos, so you got cos square x. That's equal to 1 by cos square x. 1 by cos square x equal to secant square x. So we got the answer. Right. Now let's try some more. D by dx of log x divided by x. So U is equal to log x, V is equal to x. Okay. U dash is 1 by x, V dash equal to 1. So the formula is U dash V. So U dash V minus UV dash divided by V square. 1 minus, good, log x. Yes, correct. Good. That's the answer. So I can give you some more now. Okay. Difficult things I'll give. So do it. It's not difficult actually, it's easy. You want to say, or you want to do it in a notebook and then how? Yeah. Hmm. Yeah. Hmm. Hmm. Okay, so you can take e power x common on the top. So you'll get x minus 1 divided by x square, and this is the final answer. Right? Okay. Now a small trick. So we don't use UV rule here, U by V rule. Okay. The answer is 2x. How we got it? We first divide x cube by x. Okay. when you divide, right, this is x cube divided by x to the power of 1, that's x to the power of 3 minus 1, that is x squared. So what did we do? We did the first algebra. This is algebra. First you do algebra, then calculus. That's why the golden rule in both and in the entire calculus is simplify before you differentiate or integrate. This is the golden rule. Okay, so see if differentiate or integrate. Okay, so once you simplified, you got x square, and for x square it is 2x. So now I'll ask you similar question. I have d by dx of sin x cos x plus cos square x divided by cos x. So if you consider our entire numerator as u and then denominator as v, it will be a very long thing. Yeah. See what I'll do. I take off cos x common from the top. Then I get sin x plus cos x. Right? I took the cos x common. Then divided by cos x. So what I can do? Then you just have to differentiate sin x plus cos x. Then you will have cos x minus sin x. Okay, now I'll have to tell you a joke. Okay, so one of the students actually asked, okay, so when he learned, right, he learned the formula. When I asked him the formula, tell me all the trigonometric rules and all, right, he said, yeah, trigonometric rules are very easy, sir. Okay, then I asked, tell me for what is for the tan. Oh, he said tan is equal to sin by cos. So, oh, I see. Okay, then didn't say x. Okay, he just said sin by cos. Okay, then I asked, okay, for secant. He said secant equal to 1 by cos. Okay, so oh, very good, very good. Okay, then I asked him, okay, then you try to do what is this? Something is given as sin x by x. Okay, so what he did was, oh, this is easy, sir. You just say cancel out this, and that is sin. Okay, big blunder. Okay, so first of all, learning these things, tan equal to sin by cos kind of thing, right, is that is wrong. Okay, so I just would like to, this is wrong. Okay, why this is wrong? Because we must have something, tan x is equal to sin x by cos x, sin x by cos x. Here also you can't cancel this like that. Okay, that is wrong. Understood, right? So you cannot cancel that. Okay, so if you are cancelling, it's almost like, for somebody you have taken off the entire skin, asking him to stand there. Okay, sin x by cos x. So don't do that. So the reason why I give that is, now next question for you is d by dx equal d by dx of sin x divided by 3x square. Yeah, work out. Yes, it's for you to work out and tell me the answer. So you are saying u equal to sin x? U is equal to sin x, okay. Okay, good. So u dash, correct. Correct, good. Therefore, now we have to apply the formula. Yes. How much is that? 3x square whole square, right? Yeah, this is correct. Okay, but you have to write in a simplified form. So there is x to the power of 4. Yeah, correct. It's good. So what and all we learned today? Okay, we learned, started with the differentiation, and I just gave an example of forward function, inverse function, all that stuff. Then we gave a power rule. Differentiation of x to the power of n is n into x to the power of n minus 1. Then we did some questions. We talked about monomial, binomial, trinomial, polynomial. Okay, so I'll just go back because I will be starting another one. Okay, before that confuses, I just want to revise. Okay, that's the reason I'm revising. So we started with this rule, explained about these functions. Then we got a differentiation of x to the power of n is n into x to the power of n minus 1. We call it as a power rule. X cube 3x squared differentiation. Then for x to the power of 1 we got just constant. 3x cube is just 9x square. So like that we did the examples there. Here if you have constant alone, that means no x, nothing, then its differentiation is 0. Okay, but with the 3x it is not 0. And then we did the trinomials differentiation. So we did lot of examples on that, so became confident. Then we talked about if it is a t and then you have another one, this is an, there is no t, that's why this becomes 0. That also we tried. Then we went ahead with a negative thing for negative minus 20 x to the power of minus 1, which is minus 21. Here also we did it pretty fast. Then I gave you few rules. 9 rules are given. Differentiation of e power x is e power x. Differentiation of log x is 1 by x. Cos x for sin x cos x, for cos x minus sin x, for tan x secant squared x, for secant x tan x, for cot x minus cosecant squared x, for cosecant x minus cosecant cot x. Last one, d by dx of a power x is a power x into log a. We have not done any question on this last one, so we have to do that questions. Okay. Then we went addition. You just add the addition rule. Then uv rule, u by v rule. So you have product of two functions. When to use uv rule, when not to use uv rule. So assuming u dash and v dash, all the things we did product rule. Many questions we practiced, and then we came to the u by v rule or quotient rule. There also we practiced, and I suggested simplify anything before you differentiate or integrate. Okay, so these are the things, common mistakes we should not be doing. Okay, up to this we have got. Okay, now something to do with the a power x. Okay, a power x is d by dx of 7 power x. So we first need to remember the e power x formula. So for this it is same as 7 to the power of x multiplied by log 7. This is that extra thing comes. Okay, this is the answer for that. All right. So now let me give you one question. E power x divided by 7 to the power of x. I am doing it, don't worry. So this is the one we have to do, dy dx of this. I will write it close. Sure. So e power x divided by 7 power x. So u is e power x. How is the log? That is a rule, no? The rule is this: d by dx of a power x is a power x into log a. Okay, that's the rule. Here v is 7 to the power of x. So u dash is e power x only. V dash is 7 to the power of x into log 7. So applying the rule, you will have u dash v, that means e power x into 7 power x minus uv dash e power x into 7 power x into log 7 divided by 7 power x whole squared. So that gets simplified. You have this both the cases. So I take that common. Then you have 1 minus log 7 divided by 7 to the power of x square whole square becomes 7 to the power of x into 7 to the power of x. It's a 2x. So that's the final answer. Right. So now comes the fantastic one, which is called a chain rule. I'll explain this. You see whether you have a confusion. Okay. If we have a confusion, then we will defer this to the next class. If you don't have a confusion, we will do it now. Alright. So I will first go back and explain d by dx of x square, which we know is nothing but 2x. Actually something we should be writing, but we don't write that. What is that? If whatever is here, that we have to write dx by dx. Whatever is here. But dx by dx is equal to 1. That's why we did not write that and we just said 2x. Right? This is what we did. Now let us suppose I have d by dx of sin x whole squared. Now we get a doubt. Should I use d by dx of sin x first, or should I use, because there is a 2 is there, I should use the power rule? Right? I'll first give the answer and then I'll explain the entire thing to you. The answer is 2 sin x. So this 2 will come there. Sin x to the power of 2 minus 1, because the power is for that. Then you differentiate this fellow, d sin x by dx, which means this is 2 sin x. Differentiation of sin x is nothing but cos x. So this is the answer, final answer. So where is this chain coming into picture? Okay, so the chain is like this. Now all the rules whatever we have done, okay, they will have small change. The rule, we have to chain differentiate. See, I told you here, right, we differentiated x and x, we got 1. So we have to differentiate. That's what the rule I'll tell now. Okay, the rule is d by dx of any function to the power of n. So now what are these functions? This function can be like, it can be x, or it can be a sin x, or it can be a cos x, or it can be e power x, anything. Got it, right? If you get into this form, then what you have to do is, the original formula is modified as n f of x to the power of n minus 1 into f dash x. That means whatever is inside, right, you do the differentiation of that. So we need examples to use this formula. There is another formula also. This is for the first one we modified. First formula we gave, right, power rule. We modified that. The second is for everything. For example, you have d by dx of e power f of x. So the answer is, it is e power f of x multiplied by f dash x. See, this is that extra thing. This is called a chain. Got it, right? So you keep on getting this chain. So third one. So third one is d by dx of sine f of x. So sine is first visible. So differentiation of sine is cos f of x. So write as is with a cos multiplied by f dash x. See, whatever formula we did earlier, that f dash x is coming extra now. This is called the chain rule. So our exercises in the second year in your textbook actually start with this. Alright. So how do we identify when to use a chain rule? I have, for example, x into sin x. So should I use a chain rule? No. This is u, this is v. This is a uv rule. I have sin x square. Should I use uv rule? No. Chain rule. I have sin e to the power of x. X is coming only one time, right? So chain rule. E power sin x. Chain rule. So we will go through examples for the first type now. Okay, first type meaning so we have to do d by dx of 3x plus 5 whole to the power of 9. This is what we want to do. What we know, simple rule was d by dx of x to the power of 9. We know it is 9x to the power of 8. So this entire thing is f of x. So what is the formula we have? D by dx of f of x to the power of 9. So it will come as 9 into f of x to the power of 9 minus 1 multiplied by f dash x. So 9 into f of x to the power of 9 minus 1. F of x is 3x plus 5. So 3x plus 5 to the power of 8 into, what is differentiation of 3x plus 5? Three into you don't know 3x plus 5 differentiation. So you will do them separately. Okay, you do d by dx of 3x plus 5 separately outside. Okay, so for this it is a 3 plus 0. Okay, like that you should. So now we have got 27 to 3x plus 5 to the power of 8. This is the answer. This is same f of x, right? F of x, we are considering this entire thing is f of x. So that f of x stays like that only. No, we can't change. Chain rule we don't change. So in the textbook your questions start with this only. The first question is chain rules only. Okay, go to page number. I'll tell you the page number. 166. 166. Okay, the first one is sine x square plus 5. That's the first question. Sine x square, this is x side 5.2. So first question, differentiate sine x square plus 5. So you have to see, first of all, we have that list of the formula, right? D by dx. Okay, do you have for d by dx sin x, isn't it? What was d by dx of sin x? Cos x, correct. So if it is x, I know it is cos x. Got it, right? But you don't have x here. You have something else, instead of x. This is extra thing, isn't it? So if it is x, here also x. So immediately differentiation for this is, for sine it is cos x square plus 5. Now you have to differentiate this internal thing. Differentiation of x square plus 5. So that is equal to cos x square plus 5 multiplied by, how much differentiation of x square is? 2x plus. So you got 2x into cos x square plus 5. This is the answer for the first question. Okay. So second question. What I said earlier, you just tape it like that only. If you don't understand this part, we will revise again. Okay, if you require. So dy dx of cos sin x. So write down the formula. What we know? We know dy dx of cos x, that's equal to minus sin x. Here x, here x. But this is not x, no. This something else is there in the bracket. Correct? So that something else you have to differentiate again. So first thing is, for cos, it's minus sin x. So at this time you don't disturb. First write it as it is. Now differentiate this cos x. So the answer is minus cos x into sin x. This is the answer. Third question. Question number 3. Sin ax plus b. If you want, I can try a different method here. See whether this new method will help you. Okay. So let ax plus b, whatever you have here, right, that's equal to t, something as a t. Now differentiate both sides. Differentiate this side and differentiate this side. Okay, that means differentiation of ax plus b plus equal to differentiation of t. This is called differentiating both sides. When I differentiate this, I get a plus 0 on the left side. When I differentiate this, you have dt by dx. So a is equal to dt by dx. Okay, so what I will do now is, I will replace sin ax plus b. I will write it as sin t. Then I differentiate this, differentiate sin t. How much you will get? Cos t. But we want d by dx, right? So whatever you have got cos t here, multiply with this one, whatever you have dt by dx, right? So multiply with dt by dx. So that's equal to, answer is cos t into dt by dx. That's equal to a into cos t is replaced ax plus b. I am not sure whether you like this method or the previous method. This method is used in the integration also. Okay, this is called a substitution. We are doing a substitution. Only thing new here is this, doing both sides differentiation. That will also come, and after 2 exercises you will get this differentiating both sides will come. Okay, so compare. If I do the same question the other way, so d by dx of this we will write, because there is a sign, we will write as a cos ax plus b, and then you differentiate this. So for that you will have a plus 0. That's why answer is a into cos ax plus b. So which formula I used? I used the formula d by dx of sin f of x equal to cos f of x into f dash x. So two different methods. Okay, so you have to tell me the next class, right? When you go to the next class, this method is good or this method is good. See, this method is by formula, this method is by substitution. Okay, go backwards. Here we did not put any t, we just said for sine it is cos and put the entire thing there and differentiated this. So this is what actually they recommend in the textbook. So you can do either way, both are correct. The t method also is correct. Okay, this method is also correct. So because you are substituted as its sin t, you will first differentiate that with the t, then multiply dt by dx. I'll do one more question with this t method, or shall I stop for today? No more confusions. No, stop in the sense I won't tell extra, but we will go revision or we'll talk something different. That's what I meant. Because I don't want you to get overloaded. So see, these questions definitely both 1 mark as well as 2 marks questions will come. From here onwards, each exercise, okay, will have a question. Okay, so the type of rules we talked about today, the first one is a power rule, and then we have got various rules for addition of functions, multiplication of functions, quotient rule. Then we had formulae for sine differentiation, differentiation of sine, differentiation of cos, differentiation of tan, differentiation of secant, all this formulae. Then we did the product rule and we did the quotient rule, because this product rule and quotient rule were covered in 11th standard. That's why they don't actually put it in the textbook, but that's used in many places. Okay, so that we covered UV rule and U by V rule. So we had used the a power x differentiation also, or we gave an example of 7 to the power of x and we differentiated that. Okay, then we tried to introduce the chain rule, and we had done couple of questions in chain rule. That's when we found out, right, wow, chain is little bit difficult. Okay, so actual exercise questions we have done only 3 questions. We'll continue with the chain rule next class. In fact, maths will be there for the entire next week. Maths will be there. After a few questions, few exercises, I will stop the maths. Then the next week, physics. All right. So tell me your major questions in any page you want me to go forward, backward. I'll go and then explain to you. One more time if you want me to explain. Huh? This page? No need. Sure. Okay, I'll send this PDF. So I'll be putting this on the YouTube also. Okay. I'll tell you where I put the YouTube channel. Okay, so entire thing you can view one more time if you want. All right. I'll give you the YouTube URL also. You subscribe to that channel, and you can keep getting notifications. If I post something else also, you will get to know there. All right. So that will be better than PDF. PDF for temporary. Even the other day I told that electric field and flux and all the things, right? So that also I recorded. Okay, that is also available. In fact, I think electric flux already I had put on the URL YouTube I had put. Okay, uh, so I'll give you. Sorry, no, I never said your name. No, I never said your name, isn't it? Even my name also nobody knows. I just put there. I am not telling my name. I am not telling your name. No problem. Oh, next time you won't talk, is it? No, yeah, it's actually very low because your voice will be very low, because your this one is very far off from the mic, right? It will be very low, very far off. You will see actually you hear, and next time I think I can actually cut off your voice in case you have any objection or a problem. Okay. Uh, yeah, I'm just saying, I mean, as long as we don't tell the names, not an issue actually. Okay. uh, so right then, okay, I'm stopping then. If that's the case, I'll stop it.